Welcome back to our spring semester. We're going to pick up with where we left off with our similarity unit. Today we're going to talk about how do we prove triangles similar. So let's take a look at this quick do now. John stated that the triangles below are similar. How does he know based on the given information? And then write statements which compare the corresponding sides and angles. So this is a good little review of what it means to be similar. So look at your given information, pause the video, and figure out which method we could use to prove the triangle similar in this situation. So hopefully you realize we were given two congruent angles, so that gives us what we call angle-angle similarity. Remember, you don't need all three angles, because if you know two are congruent, the third pair is automatically congruent because all the angles have to add to 180. So this is an example, again, of angle-angle similarity. This is also the most common method that's used on the Regents, if we have a Regents, but just keep in mind, this one is very popular. So let's write a couple statements comparing the corresponding sides and angles. So obviously, angle A is congruent to angle D, angle C is congruent to angle F, and angle B is congruent to angle E, because those were given to us as congruent measurements. The sides, we could use the angles to help us. AB is going to be congruent to DE because they're in the same spot. BC is going to be congruent to EF. And finally, AC is going to be congruent to DF. Okay. And just a quick reminder of the three methods that we do use to prove triangles similar. We learned this in our last lesson from last semester. So angle, again, I told you guys before, that is definitely the most common one that shows up, especially in proofs. We have side similarity, which is not that all the sides are congruent, it's that all three sides are proportional to one another, meaning you can set up a proportion and the same relationship exists amongst the three different sides. And then we also have side angle side similarity, which again means you have one pair of congruent angles and the sides on either side of that angle are also in proportion. But again, I'm going to star angle. You'll even see in our examples today, it's the method that comes up the most. So we're going to run through three different proofs just to show you kind of how the proofs look. It should feel very similar to proofs we did last semester. It's just now we're doing similarity instead of congruence. So, prove triangle AEC is similar to triangle DEB. If you look at your picture, you do have some givens. So, we are given, even though it's not explicitly stated, that AC is parallel to BD. Notice the little triangles on those sides, those mean parallel, okay? So, that is really our only given. So, let's see from there how we can get the two triangles similar. Well, we know parallel lines give us many different angles that are going to be congruent. We have alternate interior and we have corresponding. In this picture, we're going to have alternate interior. Here's our little Z. So I can use angle C and angle B. And technically, I could make a Z going the other way. And I can use angle A and angle D. Both will be pairs of alternate interior. The other thing we can use, hopefully you noticed it in the picture, we have vertical angles as well. So just looking at that, I already know it's going to be angle-angle similarity. And the method that you choose, whether you use both pairs of alternate interior or use the vertical and one pair of alternate interior, really doesn't matter. It's personal preference. I'll use one pair and then the alternate interior, and the vertical, just so you see the difference. So I'm going to say angle C is congruent to angle B. If sides are parallel, then alternate interior angles are congruent. And again, you can technically do the same thing for A and D. I'm going to do vertical angles too, just so you see that as well. Angle AEC is congruent to angle DEB. All vertical angles are congruent. And now I have my two sets of angles, so I can say triangle AEC is similar to triangle DEB. Angle-angle similarity. Done. Proof is done. Once you get those two pairs of angles, you are done. Like I said, angle-angle is really the most common method. Now, if you were thinking to use the sides, you should notice that the triangle on the bottom, they only gave us one side. So I'm not going to be able to use SSS similarity or SAS similarity because I only have one side. But now that I know the triangles are similar, I can use the fact that they're similar to solve for the missing sides by setting up proportions. Be very careful which sides correlate to which. EB and EC correlate. So it's not the ones that are necessarily like the closest to each other. I like to think of it as the ones that are kind of like diagonal from each other are the ones that we should be using in the same spot. So the first proportion I'm going to set up will be used to solve for x. Why don't you guys pause and see if you could figure out what x and y are. So for x, I'm going to use x over 24. Those are in the same triangle. The side that correlates with x is 15. Again, be careful looking at the letters. EB and EC correlate, and 36 and 24 correlate. Now I'm going to cross multiply. Grab my calculator. 36x equals 24 times 15, which is 360. Divide by 36. X is 10. Hopefully you guys got that. Okay, let's do y now. So again, I'm going to do y over 24, again, keeping it in the same triangle. 36 goes with 24, and now 30 goes with y. Again, look at the lettering in the triangle to help you. Cross multiply again. 36y equals 720. Divide by 36. Y is 20. Cool. So again, once you know the triangles are similar, you can use it to set up proportions to find your missing sides if you know at least one side in each triangle. Actually, you need two sides in one and one in the other. All right, let's try another proof. Given angle X is congruent to angle V, let's mark it. Prove the triangle is similar. It doesn't feel like they gave us a lot, but it actually will be enough. You'll see in just a minute. All right, remember, when we were doing congruence proofs, there's usually two things that we can use when you're completely out of givens. It's what I always tell my students. And those two things, if you remember, were vertical or reflexive. One of them is in this picture and one of them is not. Which one is it? Hopefully you realized it's vertical, and that's going to be our second pair of angles. Angle YZX is congruent to angle WZB. Had a brain fart there for a second. All vertical angles are congruent. I have two pairs of angles, so I can say they are similar by angle-angle similarity. I told you guys it's used a lot. And we're going to run through one more proof. This one, it might help if you redraw the pictures. People get confused because there's technically three triangles in this picture, but we're only using two. So they want me to prove ABC, which is the whole, is similar to BDC, which is the one on the left. I think drawing it like that helps, okay? So I'm going to give you guys a sec. See if you can write this proof on your own. Keep in mind, I don't know any of the sides, so it's probably going to be angle-angle similarity. All right, so notice that angle B is a right angle. That's the big triangle that has angle B as the right angle. And then they tell me I have an altitude. We know altitudes form right angles, so I know both triangles have a right angle. So that's definitely going to be important. So let's write that. Angle BDC is a right angle. Altitudes form right angles. And we know they're congruent because all right angles are congruent. So that's one pair of angles. The second pair, again, is not as obvious maybe, but if you redraw it, I think it helps. Look at the lettering specifically. Where is going to be the second pair of angles? Again, I'm out of given, so you're looking for something that's in the picture that we can just tell by looking at it. And that is, again, and this one is reflexive. They both share angle C. And finally, I have my two pairs of angles, so the triangles are similar. Again, by angle-angle similarity. Hopefully that wasn't too bad. This is a nice little warm-up lesson for the semester. The proofs are going to get a little more advanced as we go through the unit, but for today, this is all you need to worry about.